Hello, today we're going to talk about a very important topic in calculus, the derivative. And we've actually been talking about it the past few days. Whether we're determining the slope of a line tangent to a curve, finding the velocity of an object at a specific time, remember that's instantaneous velocity, or finding any other instantaneous rate of change, we ultimately use what's called the derivative of a function. The derivative of f of x, we use this notation, f prime x, this little tick mark here. But we say the derivative of f of x. So the derivative of f of x is actually that limit of the difference quotient we've been working with the past few days. Limit as h approaches 0 of f of x plus h minus f of x all over h. Past few days we've been using a plus h, but here we're talking about our function in terms of x. So this is in general. Or this is an alternate form of the derivative, and this one we won't use too much in class, but this tends to be used in the AP test on occasion. So you'll see some multiple choice questions with this format. But all it is the change in y over change in x. Same here, it's just a slightly different format like we've been looking at the past few days. To differentiate just means to find the derivative, right? To differentiate, that's the action of finding the derivative. Something is differentiable, we're describing a function as differentiable at x at a specific point if that limit of the difference quotient exists. So we can say it's differentiable. We can take the derivative at that point. So that means we can find the slope of the tangent line at that point. Or if we're talking about velocity, we can find the velocity at that point. F is not differentiable at x if the limit of the difference quotient does not exist. So if we get infinity, negative infinity, or we don't get the same thing on both sides, that means the limit does not exist, and it's not differentiable. We've already talked about a couple of the applications of the derivative. Talked about the tangent line. If y equals f of x, then the slope of the tangent line to the graph of f of x at x equals a is the derivative of f of a. So that's just saying that the derivative at this point gives us the slope of the tangent line. Gives us an instantaneous rate of change. If y equals f of x, then the instantaneous rate of change of y with respect to x at x equals a is the derivative of f of a. So we've talked about this already, but slope of the tangent line, instantaneous rate of change. That's what the derivative gives us. The derivative gives us both of these things. Right, the slope of the tangent line, instantaneous rate of change are kind of one and the same, and the derivative gives us that value.